Welcome to a KNAUER HPLC columns tutorial with the topic normal phase and HILIC. So maybe you already watched another of our columns tutorials, and there we were talking already about silica gel based stationary phases. And here now we will also talk about this type of phase, and we will start with normal phase, and maybe just have again a look at our overview of the Eurosphere 2, what is KNAUER's most often used silica gel-based column family, and the modification types we can offer here. So you see we have different ones. The modifications you see up here are the unpolar bonded phases. They are used for reversed phase. And now we want to focus on the ones down here. These are the polar phases. They are used for normal phase and for HILIC applications. And you already see here why this is a combination of two modes in one tutorial. And this is caused by the stationary phases, because they are the same. And why can you use them now in different modes? So this is what we want to talk about now. So first of all, we want to talk about normal phase. Normal phase is a mode in chromatography. It's not so often used today, so reversed phase is more often used. But it's called normal phase just because it was the first mode ever used in chromatography. So the first separation ever made was using a polar stationary phase, and this is why we still today call these kind of stationary phases normal phase, and also the mode we are using here is the normal phase mode. So the stationary phase is a polar one. So for example, the bare silica gel without any modification can be used in normal phase because it's really polar. The mobile phase is really unpolar. So you see here, this is the difference to the reversed phase mode, where it's completely the other way around. There you use unpolar stationary phases like C18 and more polar mobile phases with water contents and a little organic content. Here it's different. The stationary phase is polar and the mobile phase is unpolar. Typically you use something like hexane in combination with ethanol or isopropanol, for example, or even heptane. The analytes you can use here are more unpolar, and this is caused by the mobile phase because they have to be soluble in this unpolar solvents. And most often they are at the same time insoluble in water. So this is really a big difference. So the analytes are completely different from the ones that you use in the reversed phase mode. So, but now let's have a look at the different modification types that we offer in our Eurosphere 2 column family and that are also widespread on the market and often used for normal phase applications. So, as I already told you, if you have a bare silica gel particle, so something like a sand particle, it's really, you can use it for normal phase applications. It has the silanol groups everywhere on the particle surface, and so it's a really polar particle. The next one you might use is a diol particle. So you have this OH groups brought with a little spacer here on the silica gel particle. And therewith you have a slightly different characteristics for the stationary phase, of course, but still you see you have polar groups that will most interact with your analytes. Another one is the amino phase with these little amino groups at the end. Again, they are brought on the same silica gel particle. These columns are, they have a little problem because they are not so stable, because amino groups are really, really chemically active and they love to react. And so these columns must be used very carefully, but still they are in some applications in normal phase really needed because they have a unique selectivity. So these amino groups offer you a selectivity that's different to the ones here or here. And another one you see for normal phase applications is the CN phase. where you have these really special CN groups, again brought with a spacer on the silica gel particle. This is a versatile column. In some cases, this one is also used in reversed phase mode, because you see it's not as polar as the other ones. So here you have a lot of polar groups. These ones are, some kind of in between. So most often this phase is used in normal phase applications, but it can also be used in reversed phase. So these 4 different modifications are the ones most often used for normal phase. And now we can talk about HILIC. HILIC is a mode that is not so popular and not so well known to many people. The word HILIC stands for hydrophilic interaction liquid chromatography. And this really describes very well what's happening here. Again, the stationary phase is polar. As I told you before, nearly the same stationary phases as in normal phase mode, but now you take a different mobile phase. So the mobile phase, again, is polar. And maybe you don't really get it from the first moment why a separation might work, where the stationary phase and the mobile phase have such a common characteristics. This is caused by the analytes and by the mechanism itself. So the analytes are hydrophilic and highly polar, and they are not retained by reversed phase. Because they are so polar, they won't interact with unpolar, for example, C18 chains. And even with really polar reversed phase columns, you won't get any resolution between the peaks. So maybe they elute in the dead time of your column, and you can't use it. So they can also be not separated in normal phase mode because they are hydrophilic. So these analytes won't be soluble in hexane or heptane, and you can't use water or a high polar mobile phase in normal phase mode. Then it's not normal phase mode anymore. So what you do here, you use a mobile phase that consists of water and a modifier, like in reversed phase mode, really it is. And the trick is now that you build up an aqueous layer between the stationary phase and the mobile phase. So the most of the interaction of the analytes is not happening between the stationary phase itself and the analyte, but between this aqueous layer and the analyte. And therewith you can use exactly the same stationary phases as in normal phase, but now in the HILIC mode. I already told you, HILIC means hydrophilic interaction liquid chromatography, and it combines the some characteristics of the 3 major modes that we know from chromatography. So you know normal phase and reversed phase, and there is also the ion chromatography, what is a really well-known mechanism for HPLC. And HILIC combines kind of like something from every world. So the stationary phase, as we saw, is the same as in the normal phase mode. So you can really use the same column that is offered for normal phase here for your HILIC application. The mobile phase would be a mixture of aqueous, most often buffer systems. Sometimes buffers are not needed, but most often it's recommended. And organic modifiers like acetonitrile. And this is like the reversed phase mode. So the element is really similar to reversed phase. But the field of application, of course, is different. So you have polar compounds, and most often they are ions. They have a charge somewhere, and can also be maybe separated in ion chromatography. And they are typically used in this mode. So this combination we call the HILIC mode. So you can say HILIC is normal phase chromatography of polar and anionic and ionic compounds under reversed phase conditions. Let's shortly see how this works. So maybe, for example, you have here your Eurosphere 2 silica particle. So a not modified particle, only silica gel. And with a mobile phase, that is typically consisting of at least 80% of acetonitrile and just 20% or even lower contents of water, you are flushing your column. If you use more water, you have the problem that the interaction may get lost. So yeah, this is a good number where to start with 20% of water. And this is the water-rich layer that's built here on your silica gel particle, because you have these little silanol groups, so SiOH groups, and they love to interact with water. This is the case why you can never use water in normal phase mode, because it loves the column and won't get off the column anymore. So in normal phase, you avoid any water. And here in HILIC, it's completely the different way around, because you want the water to interact with these particles. And if you have now here your water-rich layer on the particle, you have the hydrophilic partitioning of your analyte. So it's really not really interacting with a particle, but with a hydrophilic layer here. So this is what the analytes do if you have a typically HILIC mechanism on SE columns, so on pure silica gel columns. And you can imagine there are molecules that can be separated in HILIC and also maybe in reversed phase mode. And if you have an analyte where you can do this and compare the both modes, often the retention times are inverse, so the elution order is inverse in HILIC compared to reversed phase, just because the mechanism is completely different. So some analytes that are not retained in reversed phase or really bad returned in reversed phase can be used in HILIC very well. So let's have a look. Again, these are the three phases I showed you before. So bare silica gel, diol phase, and the amino phase from Urosphere 2 can be perfectly used also for HILIC applications. And there is a fourth modification that we can offer that is specially made for HILIC, and this is the Urosphere 2 HILIC phase. This has really special groups on it, and just let's shortly see what is happening on this one. Here you have your water-rich layer, again on the Urosphere 2 HILIC particle. But as you have here these chains with different charges, you have not only the hydrophilic partitioning of the analyte, but you also have weak electrostatic interactions with the charged groups here and here. So you have a combination of retention mechanisms. Yeah? This is really interesting. And for some molecules, ionic molecules, it's really interesting to use such a particle, because you have even a better retention than just in the classical HILIC mode on a bare silica gel particle. So I hope now you got an idea of what normal phase and reversed phase particles look like, and also what HILIC means.